Hello, good evening, ma'am. Is my voice is audible, ma'am?
Yes, sir, it is audible, sir.
Okay, ma'am. Thank you so much. Let's start the session for today.
Sure, sir, sure.
Okay. Check the recordings. Okay. Okay. So this is Control Engineering Week 11, and we have to discuss the assignment related questions. Okay. So before that, actually, let me introduce something related to state space analysis. Okay. So this week 11 is related to state space analysis. So first of all, why we are doing state space analysis is the first question. Okay. The question is that actually suppose because we can find the transfer function of a system. Okay. By using block diagram reduction, by using Mason's gain formula. So, but why we require state space analysis? So generally, what is happening? The transfer function by using Mason's gain formula can be only derived for a linear time invariant system. Okay. If a system is LTI system, then we can able to use the Mason's gain formula, okay, then to find out the transfer function. But if a system is linear time variant system, okay, which is depends on the time at every instant, then this Mason's gain formula cannot be applied. Okay, this Mason's gain, this cannot be applied. Okay, so at that time, what to do? How you find out the system response for any type of input? So that thing can be done by using state space model. Okay, so this state space model came into picture. Let me add someone actually. Okay, so let me quickly go through actually the state space model. So I told you that transfer function of a LTI system can only be calculated by using Mason's formula. But if a system is like depends on time, okay, it is linear but it depends on time, but it's not LTI system, then you cannot use Mason's formula to find out the system response. Then at that time, what you do, you require the state space model to find out the transfer function on the system response. So generally what is happening, the state space model is generally time variant system. So it is represented with respect to derivative of the system. Like x star is means it will be dx by dt. Okay, x star means dx by dt. So this x star is generally represented by ax plus bu. Okay, and our output y, which is represented by cx plus du. This is the general representation of a state model. Okay, so what is a state vector? This x is nothing but a state vector. Okay, this x is a state vector. Then x star is the differential state vector. Okay, differential, we can say state vector. Okay, what is u? U is this input vector. This is an input vector, you can say. And what is this b? This b is the, which is called your input matrix, because it's associated with the input vector. That's what is the input matrix, you can say. Okay, then what are the remaining term? You can say, let's say a. What is a? A is called the state matrix. Okay, similarly y is your output, is a vector. And then again x, you know, x is a state vector. C is related to output, that's why it is an output matrix. And D is called a transmission matrix. Okay, remember that this D is always equal to 0. Okay, D is always equal to 0. Because why? Because generally our system does not consist of an active elements. We are all considered the passive element, like RS is type of system which are passive. Okay, so if any active element is not present, active element means like you can say OPAM is active element. Okay, So if there is no active element, then this D transmission matrix is always 0. Okay, so just remember that. So uh, what is a homogeneous system? Homogeneous system means if your input is 0, this will be represented by x star equal to ax. Okay, this is a homogeneous system. This is the total system which are represented by this equation 1, or you can say this is equation 2, and this homogeneous system is represented by equation 3. Okay, so this is a overall idea about the state space analysis. Okay, so what, just remember that what do you mean by state? State means what? State gives the future behavior of the system, okay, based on the present input. Remember that state gives the future behavior of the system based on the present input and also based on the past history of the system. Okay, generally the past history means what the input and what is the behavior of the system in the past, that is described by the state variables. Okay, this is generally described by the state variables a, b, c and d. Okay, these are all state variables. Okay, generally the number of state variables you can say in any system is represented by the highest degree. Suppose a differential equation is there, then the highest degree gives the number of state variables. Okay, number of state variables is defined by the highest degree in a differential equation, or also this is nothing but the sum of the capacitor plus inductor in the system. Okay, remember that, because these are the energy storing elements and that contribute to the differential equation order. Okay, suppose in the circuit L and C is there, this is second order system. Okay, suppose 2L and 1C is there, this is third order system. So number of order of the equation define the number of state variables. Okay, so let me go through some questions related to the state space model. Let me go to question number 1. Okay, so in this question just I have prepared some question for you. So the question is that write the state model to the differential equation. So y double triple three is triple order derivative. Okay, this is generally nothing but dqy divided by dx cube, like that you can say. Okay, this is the third order derivative of the system. Like that, y double dash is the second order derivative. Okay, so generally this is a system which is represented by a differential equation. Now he's saying that find out the state model. You have to represent the state model in terms of x star equal to ax plus bu and y equal to cx. Because d I told you already this is always equal to 0 in any system. As you're dealing with control system, generally these are passive elements. Okay, so this d part will never come. Okay, so y equal to cx. So this is the state model equations. So in that state model equation, you have to find out what is A, what is B, and what is C. Okay, these are the three parameters you have to find out. Now, how you find out? From this differential equation. So what you do first, remember that, let's say you are choosing y equal to x1. Okay, let I am choosing like that. Let I choose y equal to x1. If y equal to x1, this is my equation number 1. If y equal to x1, then if I take the derivative of this y, the derivative of this y equal to y dash. Okay, and if I am taking the left side derivative, also I have to take the right side derivative. Right side is x1 derivative is x1 dot. Okay, the x1 derivative is x1 dot. Now let's represent this y dash equal to x2. I am representing this variable as x2 because I have to find out x is a vector. Okay, and x here in this case, because you see in this equation x star equal to ax plus bu, and x I told you x is a vector and it depends, because your x star is nothing but a differential state vector and it depends upon the order of the equation. So order of the equation is 3. That's why in x star this vector will contain some variables like that: x1 star, x2 star and x3 star. This you have to represent. X star is something like that. And how x will be? X is something like that, only x1, x2, x3. This is also a vector, state vector. This is state vector, this is a differential state vector. And as the order of the equation is 3, you have to represent, you have to create a vector like this. Now my aim is to I have to find out what are these x1 star, x2 star and x3 star in terms of x1, x2 and x3. So first what I did, I have taken this y equal to x1, I represented equation 1. Then I have to take the differentiation of that, so it will be y dot, which is first derivative, x1 star equal to, I am just representing this, let's say this is x2. I am assuming that this is x2. Let this is equation number 2. Then what you do, you have to take the double derivative of that, okay? Then put double derivative. If the double derivative is what, now your y dot equal to x2, right? Your y dot equal to x2. So you have to take the double derivative. Then what you do, the left side derivative you have taken y double dash, the right side you are assuming that this y dash equal to x2, so its derivative is x2 star. Okay, now let assume that it is something variable x3. Let assume it. Okay, so now this is equation number 3. Now similarly you have to do the third derivative, because you require the third derivative. So third derivative is y triple dash, which is, we have assumed that this variable is x3. So if you take the left side derivative, you have to take the right side derivative. Right side is x3, its derivative is x3 dot. Okay, this is equation number 4. Now you all plug in all these values in this equation, the main equation. Okay, you can say this is the main equation. Put all this value in the main equation. So what I put in the main equation, y triple dash, see y triple dash is nothing but your uh, x3 star. Okay, so I'm putting this value here. This will be x3 star. This term is x3 star. Okay, plus 6 times of y double dash. See, y double dash is nothing but, what is y double dash? Y double dash is nothing but your x3. Okay, so here I put x3. Okay, similarly 5 times of y dash. Y dash is what? X2. So you write down x2 plus 7. What is y? Y you have taken x1. So write down x1. This is equal to 10u. Okay. Now in the first equation, what is our aim? Our aim is to find out x1 star in terms of x, x2 star in terms of x, and x3 star in terms of x. So you see here from this equation 5, you find out x3 star. Okay, what is x3 star? X3 star is nothing but 10u minus, in terms of x1, 7x1 minus 5x2 minus 6x3. Okay, this is equation number 6. So I'm just making a bracket of the last one, because this x3 star is now in terms of x1, x2 and x3. Okay, now you have to find out similarly x2 star. Where is x2 star is written? This equation, x2 star is x3. So write down, just I'm erasing the right hand side. Are you following me how I'm writing these equations? So x3 star we have written in terms of x1, x2, x3. Then you come to x2 star. Okay, first you write down x1 star. X1 star is what? X1 star is equation 2. X1 star is nothing but x2. Okay, similarly x2 star. X2 star is what? X2 star, where is that x2 star? In equation 3, which is x3. And what is x3 star? X3 star is nothing but 10u minus 7x1 minus 5x2 minus 6x3. Okay, now you find out the coefficient now. Okay, so what is the coefficients? Now you have already represent the system in this format, x star equal to ax plus bu. Okay, so here in the first equation there is no u term is there, so u term is 0. In the second, this expression u also 0, but the third u is there. Okay, so write down what is the coefficient of this matrix is a. So write down the coefficient of a. A is nothing but what? A, x2 is there. In x1 star, x2 is there. X2 star is nothing but the middle term. Okay, okay, x1 star equal to x2, because it has to, you can write like this, 0x1 plus 1x2 plus 0x3. So now you find out the coefficient 0 1 0. So this will be 0 1 0. Okay, similarly you write down x3. X3 is what? You can write down 0x1 plus 0x2 plus 1x3. Okay, so this will be 0 0 1. Like that you have to write the coefficients. Now here in x3 star, what is the coefficient? Minus 7, minus 5, minus 6. These are the coefficient A matrix you got. Okay, but what is the general equation? X star equal to ax plus bu. Okay, but b you also find out. U is the input matrix, so I am writing the coefficient b. B because in the first equation U is not there, so coefficient is 0. In the second, x2 star U is also not there, so it is 0. In the third equation, the coefficient of U is 10, so write down 10 here. So this is the B matrix. Are you following me?
Yes,
How,
sir.
then how I've written A and B, and similarly you have to write another equation y equal to cx. Okay, means you have to represent the y in terms of x. If which equation it gives y in terms of x, y in terms of x means this is a matrix, this is a vector, x is like that, x1, x2, x3. Now you see in y which term is there. See in this is the first equation which is giving y equal to x1. It means it can be represented by 0x1, sorry, x1 is there, so 1x1, its coefficient is 1x1, plus 0x2, x2 is not there, x3 is also not there, so it can be represented by 1 0 0. So this y vector is nothing but 1 comma 0 comma 0. So you can write C matrix is nothing but your 1 comma 0 comma 0. So these are the three coefficient. Okay, from this differential equation, this is the answer. Okay, this is A and this is B and this is C. I think it is clear to everyone how I have written this. Any doubt, then you can ask me. I will repeat again.
Sir, C alone, you say it once, sir.
C means, ma'am, this C matrix is related to output Y and input state vector. Now you see your where is your output Y is related to X. So you can see in the first equation only Y you have taken X1, right? You have taken Y equal to X1, then you can represent this equation. X1 means only X1 coefficient is there. X2
Yes, sir. Okay.
coefficient 0, X3 coefficient 0. That's why if you multiply this
100.
1 0
Okay.
0, right?
Understood, sir. Thank you. Thank you.
So this is the way you have to represent your state space matter from the differential equation. Okay. Now suppose I'm giving another question here. So this is the, you have to also find, I'll give some varieties. Okay, first of all from the differential equation. Now suppose one transfer function is given, then how you write the state model. Same way we are not going to do anything extra. Okay, so what you do first for this question, how approach this, just to simplify this equation. Y equal to y of s is something is given, y of s by u of s. Okay, this is given, so k is here and 2s plus 3, okay, divided by s square plus 6s plus 7. This is the equation is given. So what you do here, you have to assume, okay, always what to assume here, this is a Laplace domain. Okay, in Laplace domain, what to do, this s square, this is the second order equation. Second order equation means now you have to say that your x vector, this x star is a, x star is what, x star is the differential state vector. So in the state vector, first you identify that your state vector, what are the coefficient. Okay, it is a third order equation or second order equation. It is second order equation because the s square highest order is 2. So it means your state vector will contain only x1 and x2. If a state vector will contain x1 and x2, a differential state vector should be x1 star and x2 star. Okay. Now we have to write a matrix which is x star equal to ax plus bu. It means if you represent this vector, there's going to be x1 star, x2 star in terms of some, because this A is a matrix which is 2 cross 2 matrix now. Okay, because here x1 x2 and C B plus BU. Okay, B is a matrix which is a, because it's a 2 cross 2 matrix, so it will be a 2 cross 1 matrix. Okay, so it will be something, you can say some coefficient assume and 2 cross 1, and this is U. Okay, so we have to fill these gaps now. So let's come to the question now. What you do here, see, wherever the constant is there, always take that constant as a variable. You choose that variable as x1. Okay, now I am choosing that variable 7 equal to x1. If I'm choosing that 7 equal to x1, then what you do, what you do next, if you choose x1, then whenever as is multiplied in any Laplace transformation, as is multiplied means it gives the derivative of something. Okay, dx by dt, its Laplace transformation is what? As into x of s. So it means whenever as is multiplied to anything, then it gives a, this gives the differentiation of that. So you have to think like that and choose that. If I choosing 7 equal to x1, then what you choose, whatever the coefficient 6, you have to choose 6 is your x. Yeah, I'm just writing down here. 7 is x1, then it gives the differentiation of that. It will be x1 star, and another differentiation, this will be x2 star. Okay, it will be x2 star. Okay, its coefficient is 1, so that is the x2 star, right? So similarly, what you do in the numerator also, you write down wherever the coefficient constant is there, you have to represent it by x1. So 3 is now replaced by x1, and this term will be replaced by x1 star. Okay, so this is the way you have to represent the system. Now what you do, your y of s is this one. Okay, so I'm writing the equation. Y of s is nothing but, writing down, okay, this k is a constant, forget about the constant will never come in state vector. Okay, that's why whenever constant is there, ignore that constant. So now your y of s, you can write 2s plus 3, previously it is there, I'm just equating the numerator to the numerator, denominator to the denominator. Y of s equal to 2s plus 3. Now 2s plus 3 will be, now can be represented by, okay, so 2, and what is the coefficient? S is replaced by x1 star. Similarly 3, and the coefficient is s2, s is now s to the power 0, we can say here s to the power 0 is 1, so 3x1, you can write down like that. Okay, so 3 is, and I'm just removing, you just try to understand how I written this. Then u of s, simultaneously you have to write down. Okay, how to write down? S square is x2 star, and 6 x, this s is now x1 star, and 7, the coefficient is x1. Did you follow how I have written this?
Yes, sir.
Okay, as you know that you have already, you have written this, then you have to just uh, arrange these equations. Okay, arrange, because you have to, on the left hand side, you should be have x1 star and x2 star. See, this is equation 1, this is equation 2. Now equation 2 को मैं arrange करके लिखता हूँ, x2 star equal to, this x2 star equal to, how can I write down? This u of s should be go to the right hand side, u of s minus 7x1 minus 6 x1 star. But x1 star is what? X1 star, I told you, x1 star is nothing but your x2. Okay, x1 star is nothing but your x2. You can write like this, x1 star, this is equal to x2, and here this is x2, and so what is the derivative? X2 star. So like that you have to write 7, this you can replace by x1 star, can be replaced by x2. Okay, so it will be minus 7x1 minus 6x2. So x2 star you got. Okay, as you know x2 star, then you only require x1 star. What is x1 star? From this, x1 star equal to x1 star equal to x2. Okay, we are assuming x1 star equal to x2. It means only x2 term is there, so you can write on 0x1 plus x2. That's it. Okay, as you know these two equation, then you can write on the A matrix. Now what is the A matrix then? This A matrix, this you have to fill up. So x1 star, this is x1 star is 0x1, so the first term will be 0, and x2 1x2, so this will be 1. Next, x2 star, come to here, come this equation, x2 star equal to minus 7, write down the coefficient first, minus 7, and here minus 6. Okay, but in the first equation, is there any term related to u is there? No. In this equation, there is no u term is there. That's why the coefficient of b in the first term will be 0. and come to x2 star. Here the coefficient of u is 1, so here b will be 1. Are you able to follow how I have written this A and B matrix here? Are you getting me? Anyone?
Yes, sir. Understood, sir.
Okay. Then if you understand, then you can tell me what is the coefficient of C, because y equal to Cx, right? Y equal to Cx
Yes, sir.
means, now tell me, you can write what is the
Y
coefficient of C now?
equal to
C, because C x1 x2. Now tell me
3.
what is the coefficient of C, because you go to y, where this y is written in this equation.
It's
Okay.
300, sir.
No, ma'am, it is 3. Okay, because this is 2 cross 2, man. This is 2 cross 2. 3 cross 3 nahi hai. 2 cross 3.
Yeah, 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 yeah.
3.
Yeah, 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 yeah.
So
Yes,
which,
sir. Yes,
what is the coefficient related to x1? x1 का coefficient 3 है. So 3x1
yes,
you
3,
multiply
sir.
like that. Okay, because it's a matrix multiplication.
Yes,
And
yes,
2x1
yes.
x1 star. x1 star is nothing but x2. So 2x2. 2x2 means it will be 2.
So 3, 2.
So these are the three,
Okay, sir. So
these are the
now it
three
is 3,
matrix.
2.
Yeah, this will be C. This is the C vector is now here 3 and
Yes,
2.
yes.
Like that you have to find out the coefficients. Okay,
2.
then you have to find out the matrix, A matrix, B matrix, and C matrix from the transfer function. Okay, now quickly I am going to the third question. The third question is related to signal flow graph. So from a signal flow graph, how you write the state model. So first of all, we saw how to find out from the differential equation. Second, we'll saw how to find out from the transfer function. Now we'll see how to find out the state model from a this is called a signal flow graph. Okay, so what you do first, let me change the pen color. Now you see, so here this is 1 by s term is there. 1 by s means it's an integrator. Okay, this is 1 by s, this is another integrator, and this is written 5. This one is 5. Okay, so now what you do, so what you do first, you first choose your x1. Which point you have to choose your x1? See, whenever this is a matrix, this is, there are two nodes is there. Okay, so in these two nodes, this is the two nodes I am choosing here. So if I choose the first node as x1, then one integrator is there. Then what is the integrator? It means if I go back, this is called a differentiator. In the forward path, this is the integrator. In the reverse path, if I go back, this is a differentiator. It means if it is x1, then the differentiation should be x1 star, right? Right, man? If this is x1, this node is x1, and this is the
Yes.
integrator is there, then the left side node should be
Okay,
x1
sir.
star. Because this is a differentiator. Difference dx
Oh,
by dt, if you do the integration, then it will be x only, right? Right. So if x1
yes, sir.
star is
Yes.
there, if you do the integration, then you will get x1. So like that, if you understand this logic, then if I put at this node, if I put my x1, then this is the integrator, then this node should be x1 star, right? First derivative, right, ma'am? And
Yes,
this
sir.
x1, you know, this x1 star, you know that
Yes,
this
sir.
will be x2, right? X1 star, always you choose x2. If this is x2, this node is
H2.
x2,
Yes,
then another integrator is there, then this node should be x2 star, right?
yes, sir. Yes, sir.
Now if you know the nodes, these nodes, then you just write the mathematics. Now come to, now come to the first node. I'm representing, this is my first node. So if with the first node, come to the first node, you write the equation. This is the first node. Which point is coming to this node? Now this is the node. At this node, one branch is coming to, input is u of s. Now I can write, this is my node. In this node, one incoming node is there. You know that in any node, incoming node equal to outgoing node.
To
So
the
write down 2 u of s. 2 u of s, the incoming node, right? So now you see how many incoming nodes are coming to this path. You can see this path. This is also incoming node, because this see arrow
3.
is pointing backside. So it will be minus 2 times of x2, right?
Yes, sir.
This one, this map, this one, this is coming backside. and this point in this node is x2. So x2 into minus 2 x2 is coming to this node x2 star, right? So minus 2 x2.
Yes, sir.
And another node you see from here, this node is also coming
Minus
back
3 x1.
minus 3 x1. So all these three nodes are coming here. Incoming node should be equal to any outgoing node is there? Yes. One outgoing node is there. This forward path.
1, sir. 1.
Yeah. This is the outgoing node. So this outgoing node, how can we represent this outgoing node?
1 by s x1 dot.
1 by s x1 dot. It means this outgoing node, you can say, uh, just a second. Uh, this outgoing node ka path 1 by s is there, but we'll not consider 1 by s, and this will be, you can write this is x2 star only, because at this node we are writing out the equations, right? So one is incoming, another is incoming, another is incoming, and the outgoing node is going from x2 star. That's why that should be equal to x2 star. Like that you have to write it. Otherwise, what you can do at x2 star, you see what are the things are incoming. So at x2 star, all these three are incoming. So you can write the equation like this: x2 star, this node is nothing but incoming 2us minus 2x2 minus 3x1, and at that point one outgoing node is going, but this coefficient 1 by sa, but at which point x2 star. So x2 star you have to write like this. So x2 star is nothing but 2u minus 2x1 minus 2x2 minus 3u. Similarly, let me choose another point. Let me see. uh,
X1 dot.
uh, x1 star, because we have to represent x1 star and x2 star, because
Yes,
here highest order is x2 star, means second derivative. So x2 star I have already written down. Now write down x1 star. x1 star कहाँ पर है? इस बीच वाला नोट, so middle वाला नोट. So x1 star is equal to x1 star equal to nothing is incoming, all are outgoing, so incoming node you have to only consider. So x1 star equal to x2, only x1 star equal to x2. Nothing is there because no incoming node is coming to this. Okay, all are outgoing. So forget about the outgoing nodes, only incoming nodes you choose. So no incoming nodes, so x2 at this node only you have x1 star, and we know that x1 star equal to x2. So x1 star equal to x2, it means I can write the coefficient of x1 equal to 0. Now you write down the state equation. Now from these two equations we are enabled, we can write the A matrix. So here is x1 star and x2 star. This can be represented equal to x1 x2. How can I represent A matrix? Now see, 0 x1, so this will be 0, and 1 x2, this will be 1, and x2 star minus, since the coefficient minus 3 है, and this will be minus 2. So now A matrix is over, right?
minus 2.
And the B matrix here,
Yes,
the
sir.
B matrix in the second equation is related to x1 star, so there is no input is there, input is not there, so you can say right 0. And the first matrix, which the first equation which is related to x2 star, and its input
One.
coefficient is 2, so you can write 2. So this is your u. Okay, this you can write this is so A, this one is your A matrix. This one is your B matrix. Now find out the C matrix. C matrix means y equal to cx, right? Now you write down the equation of y in terms of x. Now come to the last node. Coming to the last node, this last node here, this node is connected directly to the output y. So you can route output y equal to, what are the incoming nodes you see? Incoming nodes is one is 5x1, another is this node, okay, this node which is 2x2. So
2 x2.
5x1 2x2 means y equal to, you can write down 5 and 2. Okay, this is your x1 comma x2, right? So this is your C matrix. Understood?
Sir,
Yeah. Yes, ma'am.
sir, B alone you say it once, sir.
B, because you see, ma'am, B is nothing but
B.
B is
B
nothing but,
matrix.
yeah, B matrix is related to input, right? This is U is nothing but your input. B matrix is related to input. In
Yes,
equation
sir.
1, in equation 1 where x2 star is there is a U term is there. Okay?
Yes, sir.
But in so that's why in x2
Yes, sir.
star, x2 star, if you see on the bottom line, there is a 2 is coming. Okay? Because 2U. But in the
Okay,
but
sir.
in
Okay.
the
Yes,
equation
yes, yes.
number 2,
Yes, sir. Now
x1,
I understand.
right. So nothing is there, you write down 0 into U. That's it.
Zero, zero. Yes, sir.
So that's why it is
Okay,
0.
sir.
So
Okay, sir.
like that you have to do. Okay. So let me give an equation how we are solving this. Let another state space matrix. Let me write down. This is U is given. This is the first node. This is U. Now this one another node. This is one is given 10, and from here to here another node 1 by S is given, and again another node 1 by S is given. This one is 1 by S. This one is 1 by S. This one is also 1 by S. Someone trying to join. Let me add. But if you come late, you cannot be able to understand. Okay. So see, 1 by 3 nodes are given. So 1 by S, 1 by S, 1 by S. Okay. And this is the final node, which is having a gain of 2 is given. This one is 2. And this point is output Y.
Yes,
Now,
sir.
how he has given the feedback path, let me do that. So first of all, before drawing the feedback path, let me say that how you choose. So first of all, this is our first integrator. If I have a first integrator is there, if I write this one as x1, then what I'll write the back, I'm not adding node 1. Okay, this is node 1, this is node 2, this is node 3, and this is node 4. So now you tell me, if I'm assuming my node 1 is x1, then what is my node 2? Node 2 will be x1 star, right? Because it's just a differentiation, right? The forward path is an integrator means
Yes,
backside this one it
sir. Yes, sir.
differentiation, right? So x1 होगा
Yes,
तो
sir.
इसका differentiation x1 star होगा, and I am assuming always that x1
Yes,
star
sir.
is nothing but x2, right? If this node is x2, then
X2.
what is the node 3? It will be x2 dot, right, ma'am?
X2 dot.
If this is
Yes,
x2,
sir.
this is x2 dot, and we are,
X2 dot.
if x2 dot is what do you have to assume? X3, right? Then
X3.
if this is
X3.
x3, then what
Yes.
is this dot? This is x3 dot, right?
X3 dot. Yes,
Then
sir.
then he has given some feedback path. I'm writing that feedback path. This is the feedback path is given. So this is the backside feedback path, and this one this connected to again here. This another feedback path is given. So this will be -2 is given. This one is -3 is given, and another forward path is given from x to star y. So this one is given. This one is given here. This is a this is a forward path. Forward path I'm writing right hand side. This will be 10. Now you tell me how to write the equation. So you have to represent, because this is a C, this x3 star is coming means this is the third order vector. Okay, x3 star, x2 star, x1 star. You have to represent in terms of A. This one is to be x1, x2, and x3 plus B. B matrix would be a 3 cross 1 matrix, because this will be a 3 cross 1 matrix. Then this will be U. Okay. Then you have to write this equation first. First of all, you write down. Okay, I have just reverse. So upper one should be x1 star. This will be x2 star. This will be x3 star. Now you have to write down first x1 star equation. Let's see, find out where is x1 star is there. Go to node 2. At node 2, you can see that
No
x1
two.
star equal to x2, right? Because at this node there is no
Yes, sir.
incoming. Okay, only x1 star equal to x2. Okay, so now x1 star equal to x2, this is a fast equation, because now you write down the coefficient. x2 का coefficient 1 होगा, तो x1 का coefficient कुछ, there is nothing related to x1 coefficient, so write down 0 x1. And in this node there is no input is at this point. Now you see node 2, node 2 and input are far away, so there is no direct connection, so write down there is no input, so 0 0 u, right? This is 0, there is no input is associated, so input ka coefficient you can write 0. Now you go to x2 star, go to x2 star is node 3, x2 star is node 3, node 3, x2 star, x2 star is nothing but your x3. Now you see x2 star is nothing but x3. There is
Three.
no relation between x1 and x2 at this node, because x1 is here, x1 is here, and x2 is here. So there is no connection between these two. Okay, directly. So you can write down your x2, इसका coefficient 1 होगा, तो बाकी का coefficient 0 x1, 0 x2. And here also x3 is not there, so you can write down
Zero
0
is
x3 and 0 u. Okay, but here also no
plus
input
zero
is
u.
there also. Now you come to
U.
x3 star, node 4.
Zero u.
Whenever coming to node 4, now you see x3 star is there, and this x3 star is nothing but 10u. Okay, then feedback paths are there. Okay, feedback paths, so -2
Minus
x2
two
x2 -3 x1.
x two. Minus three x one.
Okay, so these are the three terms is there. Now here you can see x1 x2 is there, but x3 is not there, so 0 x3. Okay, now
Zero x.
just to fill up these
Yes, sir.
values, so 0 0,
Yes, sir. Understood.
right? Now you fill up these values, so it will be 0 1 0, this will be 0 0 1, and this will be -3 -2, and x3 का coefficient 0 है, so it will be 0. And now you see where is u is there,
Zero zero one.
and u 0 0, and
Zero
this will
zero
be
one.
10,
Minus
not 10, this will be
x
10.
three. Zero zero 10.
Right, this is your A matrix, this one is your A matrix, this one is your B matrix. Similarly, write down what is C matrix. You go to
Excuse
Y.
me, sir.
Yes, yes, yeah.
At node 1 or 3, sir, suppose at node 3, so we consider incoming branches.
At node 3, you just see the feedback paths. At node 3, is there any feedback paths are there with constant? Because that node should be related to x1 and x2 in terms of x1 and x2. Now at node 3, there is no term which is related to x1 and x2, right? Just to see in terms of any differential terms, you have to represent in terms of x1 and x2, and x1 x2 and x3. So at node 3, in node 3 x2 star, which is generally represented by x3, but there is no feedback path which is in terms of x1 and x2 to that node 3, right? In terms of x1 and x2, because you have to write any differential equation in terms of x1 x2 and x3. So at node 3, only x3 is there. Can any direct connection from x2 to x node 3? In 2 to 3, there is no connection, because you cannot write x2 x2 star in terms of x2, because there is no connection. Similarly, x1, there is no connection from 1 to 3. Right? You're getting my point, my sir?
Yes, sir.
But if you're not clear, then don't say yes. Just let me clarify your doubt first. You're not getting?
Actually, sir, whenever you're writing the equation, you are writing at node different nodes. So incoming branch or direct branch connected with that node.
No, no, no. Just you have to see what you have to see, sir. Actually, first of all, you have to know that what you are going to write. We are going to write a state vector in terms of ax plus bu, means your state vector, differential state vector x star, should be in terms of x and you input u, right? Now let us come to node 2. Your doubt on node 2 or node 3. Let's come to node 2 first. I'm just explaining again. No, at node 2 you have to write your x1 star, because this row I have to write first. Okay, so come to x1 star. I have written x1 star. I am assuming that x1 star equal to x2, so I have write x1 star equal to x2. But is that node X is related to X1 and X3 in any way? Let's see. X1 star, where is your X1? Here, this one is X1. Is there any path which is joining that feedback? I'm saying forward path. Can you write your X1 star in terms of X1 star? You cannot write. X1 star you cannot write in terms of X1. You see from node 2 to node 1, only one integrator is there. Can you able to connect that X1 star and X1 in any way? You cannot connect. So that's why you cannot connect X1 star in terms of X1. Similarly, come to X3. Where is X3 is there? Here X3 is there, node 3. Can we connect X3 to X1 star? You cannot connect. You cannot connect it by any feedback path or any coefficient by in terms of X1, X2, X3. Cannot connect. That's why its coefficient is 0. Can you connect this node 2 to input here? Input is at the left hand side and node 2 is here. So you cannot connect in any way. That's why you have to always connect that node differential vector in terms of the state vector. So that's why as you cannot connect, your coefficient is 0. Similarly, come to node 3. But at node 4, we can connect anything. You see at node 4. Node 4, we can connect the input by using this 10. So I'm writing 10u. At node 4, I can connect my x1. See, node 4, node x1 is between 4 and 1. So I can connect by minus 3. So minus 3 x1 is nothing but your x3 star. Similarly, at node 2, I can connect my x2 by this minus 2. So minus 2 x2 is your x3 star. So x3 star, you have to represent your x3 star in terms of x1, x2, x3. Are you getting?
Yes, sir. Means we take the backward path.
Not backward path, sir. You have to always see that can we able to connect my x vector, means differential state vector, in terms of normal vector. That's it. If you go to back the this where I have saw that this one, you can see here also there are two vectors are there. I am taking x1 and this one is x1 star and this is x2 and this if this is x2, this is x2 star. This is a 2 cross 2 matrix. Now the highest order is 2, so order is 2. Now you see how I have written this. I am writing this first of all x1 star. This is the differential state vector. Now go to x1 star. Let me assume this node is node 1. This is node 2. Now come to node 2. At node 2 x1 star is there. Now I am writing x1 star. Now you have to represent your x1 star in terms of x1 and x2. Now you have to correlate this. Now you see x1 star equal to x2, one equation is fixed because we are always assuming that x1 star equal to x2. But can we connect x1 star to x1? See, this one is x1 star. Here is x1. Can I write the equation so that x1 star in terms of x? You cannot write. Got my point, sir?
Actually, sir, I have joined late, so previous concept I am not recalling, unable to recall. That's why maybe
This is
problem.
not unable to recall, sir. I am just saying now you have to represent your differential state vector in terms of state vector. Now, if you uh, how because just I'm saying this is simple mathematics, sir. You have to represent. See why I'm writing here x1. You have to choose first of all. You have to choose the integrator path. As many as the integrator paths is there, this is the order of the equation. Okay. Now you see there are two integrator paths is there. One by s are the integrator in Laplace domain. Then there are two order is 2. Then I have to choose one integrator first. Let's see, I am choosing this integrator first. Okay, 1 2 3. I am choosing this node 3 as my x1. Then if you are going back means forward path is an integrator, backward path is a differentiator. It means this one x1, then this node 2 should be your x1 dot. It's a differentiation. I am assuming that x1 dot equal to x2. If this is my x2, then another differentiator is there which is joining my node 1. If this is x2, then this should be x2 dot because this is a differentiator. So now you have to represent your x1 dot and x2 dot in terms of x1, x2. So now you just write down this x2 dot equation. First I'm writing down the x2 dot. x2 dot, can I write in terms of input? Yes, you can write, because x2 dot is nothing but 2u. So I'm writing here 2u. Can I write my x2 dot in terms of x1? Yes, you can write. You can see this path. This minus 3 can multiply with this x1 and I'm getting x2 dot. You can see x2 dot is nothing but minus 2x2. Can I write my x2 dot in terms of x1? Yes, you can write by using minus 3. That's what. Just the mathematics. You can watch the video, okay, after I finish if you miss anything, because I cannot go back and explain anything, okay, because I have to solve a lot of questions.
Yes, sir. Okay, sir. Okay.
Okay, so just to go back to the equation, I have just described how you have to rate. Now come to question number 4. This is also you have to write the state model. So first problem we have discussed that how you write the state equation from the differential equation. Second problem I discussed how to write the state equation from the transfer function. Third equation we have solved the differential equation by using the signal flow graph. Now the fourth question is related to I have to write the state equation from the electrical network. So I told you that these energy storing elements are 2. Number of energy storage elements are 2. So number of energy storage, this L and C, so it is 2. So as many as number of storage elements are there, your order of the equation is that one. So order is now 2. Okay, because these are the terms which gives LDI by dt and this C gives C dB by dt. So this is one differentiator, this is another differentiator. So that's why we have two differentiator term is coming, that's why the order is 2. Now how to solve this equation to find out the state vector. State vector means always you have to remember, you have to represent x star in terms of ax plus bu and y equal to cx. So remember that in any electrical network is given, you have to first identify your state vector. Now what is your state vector? State vector means x, but what is the state vector here? Previously you don't have anything. That's why we are assuming that this is x1 and x2. But whenever coming practical life, you have to identify your state vector. Remember that here the state vectors are the inductor and the capacitor. And remember state vector is nothing but the current through the inductor, IL, and the voltage across the capacitor, that is VC. Remember. So state vector is nothing but current through the inductor, always current through the inductor. Current through inductor I am representing IL, and voltage across the capacitor, voltage across capacitor, which is VC. So these are my two state vector. Now I am writing this equation. This one equation and two equation I am writing in terms of my state vector. How will you write? X star. X star is nothing but IL star and VC star. Okay, these are my state vector. Now in terms of A I don't know, I have to find out because it's a 2 cross 2 matrix. So this matrix should be a 2 cross 2, which is unknown to me. And AX is nothing but your IL and VC. Okay, this is IL and VC. And C plus BU. B is your input matrix. So this definitely is a 2 cross 2 matrix. So this will be a 2 cross 1 matrix. And what is your input here? U. U is nothing but your input is VI. So this is a voltage source at the input. So this is now I can write the U matrix is nothing but your VI. Now up to everyone is clear how I correlate this equation state vector into this electrical network. Is it clear? Is it clear everyone?
Yes, sir.
Now
Clear.
we have to find out the differential equation. Means what we have to find out? We have to find out IL dot in terms of IL and VC. Because if you write the equation, if I write this is ABCD, then IL dot I can write AIL plus BVC, and similarly VC star you have to write out CIL plus DVC. Means we have to find out ABCD. What is the value of ABCD? Okay. So let's see, this one is because A we are always using here. So A1 B1 C1 D1. So A1 B1 C1 D1. We need to find out and fill that. Okay. So first of all, we have to represent this model into these equations. Let this equation is 3 and this equation is 4. How I will represent this in terms of this? Okay. So first of all, you have to find out IL dot. How can you write a KVL equation from this? So you know that whatever this current IL is going, this is the output. This output is open circuited. See here, output is open circuited. It means whatever this IL current, that should, this has to be flow in this path loop, but the only one loop is there. So IL is nothing but your IC, okay, because same current is flowing here, okay. IL, this current is coming and flowing to the IC because the output side is open. So I am writing my first equation here. I am writing down IL equal to, you can write this is IC, okay. And IC, you know what is, how can you represent a current through a capacitor? This current through a capacitor is nothing but C dVc by dt, okay. And just to simplify this, IL equal to C dVc by dt is nothing but your Vc star, right? So we got an equation of Vc star. You can see the fourth equation format. Vc star is something, okay. So if I write down that this will be Vc star is nothing but IL by C. This equation can be represented by this. If this equation is clear, I am representing this equation is 5.
Yes, sir.
Now from by looking 4 and 5, can you able to compare me, tell me what is C1? C, Vc star equal to C1 IL, so IL into C, so 1 by C, C1 equal nothing but 1 by C. Can I write like this?
Yes, sir.
But
Yes,
in
sir.
this equation 5, is there this Vc star is related to Vc? No, Vc is not related to Vc, so D1 should be 0. So that's why I'm putting here D1 should be 0, because this equation is nothing related to Vc. That's why the last row I have written down. Now we have to frame another equation so that I can fill the top row. So let me write down here. This portion I write down here. Now write a KVL equation at the input loop. So Vi equal to, can write down R times of IL
IL
plus L
plus
DIL by dt
yes, sir.
plus Vc, right?
Plus
This plus minus Vc, right? This one plus minus Vc. Now from this equation, you have to find out dl by dt in terms of other terms. So I am writing dil by
IL
dil by dt. Okay, space is not right. So dl by dt, which is nothing but your il dot, this equal to vi minus ril minus vc.
minus
Now compare this equation 6 with equation 3 and tell me what is your a1 p1. See,
minus R
minus r and
and
minus,
minus 1.
no, this is L di by dt is there na, this is L di by dt, you have to divide L everywhere, right? So one L will be divided here, so
Okay, okay,
the
sir.
VIL by L, this is R by L and this is VC by L, okay.
CCDL
So this will be how much? Minus R by L and minus 1 by
and 1 by L.
minus, uh,
1
so
by L.
IL should be how much? Minus R by L and minus
1 by
1 by
L,
L,
minus 1 by L.
right?
1
Now,
by L.
yes, but minus is there na.
Yes, sir.
Okay, so yeah, this should be minus 1 by L. And what is the, now you see the input is which equation, in equation 6 and equation 5, where is input is coming? Is equation 5 contains input? No. So it should write here Vc star is here, the coefficient is 0. And what is the coefficient of Vi in the first equation? 1 by L. So you write down 1 by L. Are you following me?
So where is the
Yes,
first
sir.
equation?
So first equation, because we have already represented na, IL dot. So IL dot means this is the sixth equation is related to the first row, right? So you see IL dot Vi by L. Vi by L is there. So 1 by L should be come here, right, sir? See here
So
1
in
by
this
L is
matrix, second part plus in 1 by L 0, you have written 1 by L
right,
0.
right, right, right. 1 by L 0.
So yes, you have told from third equation, aside first equation.
No, sir. You have to just see because six we are comparing equation because see this equation three is analogous to equation six, right, sir? Three and six are analogous because we have to represent a1 and b1 in terms of IL and VC. So
Yes,
now
sir.
see IL dot. So 1 by L का coefficient minus R by L. So we are putting minus R by L. VC का coefficient minus 1 by L. So we are putting minus 1 by L. But also because this is plus b into u na plus b into u. So u is
Yes, sir.
input vi. So what is this coefficient? 1 by L. But 4 and 5 are analogous. But in 4 and 5 you can see input is not there. So that's its coefficient is 0. Are you getting my point?
Now, okay, sir. Okay.
Now, uh, now you tell me what is C matrix then? Output equal to C into X, right? So I'm just going the next. Yeah, right somewhere here. Let me erase this on the top part. Now you have to write Y equal to CX. Y is what here? Y is nothing but your V naught. V naught is Y. Right? Write down Y equal to V naught. C matrix should be a 1 cross 2 matrix, right? And X is nothing but your IL and VC. IL and VC. Now you see, you write the equation of V output. V naught is what, sir? V naught is nothing but VC because both are parallel. Both are parallel. So V naught equal to VC. V naught equal to VC. Now you see V naught equal to VC means this part V naught nothing is related to IL. V naught is nowhere related to IL. So this is 0. And V naught is related to VC. So this would be 1. Right, sir?
Okay, sir.
Yes, sir. Okay.
So in this way you have to so this is simple electrical network I have taken. Suppose they have adding another L another C. Just write the KVL and KCL at that node. How many number of you have to always you have to choose the state vector. State vector nothing but current through the inductor and voltage across the capacitor. Suppose another capacitor here you have there, then you have to choose IL dot VC1 VC2 like that you have to take. So two inductor is there, you have to choose IL1 IL2. Similarly, the differential state vector will be IL1 dot IL2 dot. Just you
Sir,
yeah.
is there any shortcut method to solve the state equation, state model? Because we in this apply KVL and KCL equations,
No, sir.
and then we
Actually,
rearrange
there is no
in matrix
shortcuts
order.
here. Shortcuts are there in the transfer function method. Shortcuts are there in the signal flow graph. But in the electrical network, you don't have any shortcuts because this is a complex network. You have to solve. You cannot have any shortcuts, sir. Like I don't have any shortcuts for you because nobody has any shortcuts here. So you have to solve the KCL and KVL and write the equations and feed it.
Means whenever we forming the state model, we always write KVL, KCL, basic equation, then we write in matrix form, right?
Right, right, sir.
State
That's it.
model.
That's it. Because they will not in the examination they will not ask more than third order. Nowhere you will get more than third order. Because why? If also third order also it is very difficult to solve the total response. Why we're reading this? Because we are reading this to find out the total response. And the last questions are like the real questions. Here we are building up the ABC matrix. Now by using the ABC matrix, we have to find out the transfer function. Because why we're not able to find out the transfer function by using Mason's gain? Because I told you that Mason's gain formula is only applicable for a LTI system. But if any system it depends upon the time, that is time variant system, then you cannot apply Mason's gain formula. That's why state space model came into picture. That's why this type of systems are time dependent system. That's why you are getting something related to that is called differential term. Differential term means these are dependent time. You're getting some time related terms now. Now from different aspects we are building up that how we are can able to find out the state vectors, because our aim is that we have to find out the system response. For the finding out the system response we have to find out the transfer function. For finding out the transfer function we need to find out the ABC coefficient matrices. So from different questions, from different variety of questions, how you have to able to find out the ABC matrix, that is important. After ABC matrix is there, you have to find out the transfer function. For that formula is there. Then from transfer function you have to find out the system total response that we're going to solve. So these are some basics. I am just telling that how you build up the ABC matrices from. So don't rely on the shortcuts, sir. Shortcuts will not help always. So let's coming to the next questions. Okay, the next question is that already the past four question I discussed that you have to able to find out an ABC matrix. So now I'm giving an ABC matrix to you. Now I'm asking you to find out the transfer function. Now from here the question, real questions will come. Okay, so remember that actually transfer function is given by C times of Si minus A inverse into B. Okay, this is your transfer function. I'm not considering D in any question because D I'm assuming that 0, because D is 0 because we are dealing with the passive elements. We are not dealing with the active elements. That's why remember that in any questions always the D will be always equal to 0. Okay, in control system mostly. So that's why this is the transfer function formula. Once you know C value, once you know A value, and once you know B values, then you have to find out this SI minus A inverse. Okay. Any matrix का inverse कैसे निकलता है? Adjoint of that value, adjoint of SI minus A divided by determinant of SI minus A.
A.
So this is the determinant. Okay, so first of all you have to find out how to find out the adjoint of Si minus A. First this term you have to find out. For that first of all you have to find out Si minus A. What is Si minus A? S, because this is a 2 cross 2 matrix, so S should be S, you have to multiply to an identity matrix. So I'm multiplying identity matrix, you know, 1 0 0 1. It's an identity matrix. You have to multiply S, and from that, if I multiply S, then S multiplied with 1 equal to S, and S multiplied with 0 equal to 0. S multiplied with 1 equal to S. So this is our SI minus A. What is A value? So this will be minus 2, minus 3, 4, and 2. Now you subtract this 2. So this will be S plus 2, and this will be 0 minus minus 3. This will be 3. So this is 0 minus 4. This will be minus 4. And S minus 2. This is S minus 2. This is your SI minus A. So as you know Si minus A, then what is the adjoint? Adjoint of a second order matrix is very easy. So what you do? You just reverse the coefficient first. So what you do? This all the coefficient terms you have to reverse fast. So remember that I'm just writing the shortcut here. Just this is not a shortcut. You just write down how to find out in one line how to find out the adjoint of a matrix. Let's see this matrix is ABCD, and if I need to find out the adjoint of that matrix, then what you do, you place alternate this A and D. D will become here, A will become here, and B and C will not change their position, but they will be negative. B and C will be negative. So this is the adjoint of that matrix. So based on that, I have to write this equation adjoint here. So adjoint here nothing but what I told you, this position should be reverse. S plus 2 will be here and S minus 2 will be here, and the off diagonal elements they will change their uh, okay, they change their polarity. You can see this will be 3 becomes minus 3, minus 4 becomes 2.
So they change their position diagonally.
Yeah, diagonal positions will be changed and off diagonal position will be remain fixed, only they change their polarity, right? You just see.
Yes, sir.
So now this is the adjoint of that. If you know the adjoint of this, then you know what is the determinant of this. Okay, so determinant of Si minus A will be nothing but S minus 2 into S plus 2 minus 4 and 3 should be 12, so 12 this equal should be equal to 0. So this is the determinant of that matrix. Okay. So now what you do, you have to put in this formula. So C, you know C, what is the C value? C value is 1 comma, this will be C, this will be 1 comma 1, this will be C. Next, Si minus A inverse. Si minus A inverse is nothing but adjoint of Si minus A. Adjoint of Si minus A is nothing but S minus 2, minus 3, 4 and S plus 2. This should be divided by its determinant. Determinant is how much? I told this will be multiply this S minus 2 to S plus 2. A plus B into A minus B is A square minus B square. This S square minus 4 plus you can write down 12. This is the determinant. No need to equal to 0, just to find out the determinant of that. So this is your adjoint of this divided by determinant of this, and C we have already written. This is C. This will be Si minus A inverse term, and you have to multiply with B. What is the B value? This B value is 3, 5. Now you first solve the numerator part. So this is a 2 cross 2 matrix, and this is a 2 cross 1 matrix. If you multiply, you will get it 2 cross 1 matrix. So first to matrix multiplication you have to do. Okay, so S minus 2 has to be multiplied with 3, and minus 3 should be multiplied to 5. So first to solve that, I'll go to the next page. Okay, can I go to the next page, or I'll write
Sir,
here?
S square minus 4 plus 8, I think.
S square minus 4 plus 8, sir. Why? Because 4 into 3 is minus 12, right? Determinants means AC minus BD, right? AD minus BC is determinant, right? From this ABCD matrix. AD minus BC. Determinant of what is that? Is AD
S,
minus BC.
yeah, determinant of Si minus A
Yeah, what is that value? S minus 2 into S plus 2. S minus 2 into S plus 2
plus 12.
minus minus it's minus plus 12, right? This will be plus
Yes,
12. So this will be minus 4 plus 12. This will be 8, right? You are saying that, right? This will be S square plus 8, right?
yes, sir, yes, sir.
Can you simplify this by your own, or I will simplify here, or let me simplify here. Just I'm erasing these portions here to write down. So now you have to multiply this first 2 cross 2 into 2 cross 1, because you are multiplying the numerator first. So S minus 2 should be multiplied with 3. So 3 into S minus 2. Write down this is 3 into S minus 2. And minus 3 should be multiplied to 5. This is minus 15. Okay, because you will get 2 cross 2 and 2 cross 1, will get a 2 cross 1 matrix. So this is 2. And again, 4 should be multiplied to 3, so this will be 12. And S plus 2 should be multiplied with 5, so 5S plus 10. So this will be 5S plus 10. Okay, if you simplify this will be 3S minus 6. I'm not simplifying it. 3S minus 6, and this should be minus 15. 3S minus 6 minus 15. So now if you further simplify, this will be 3S minus 21. This term should be 3S minus 21, and this term should be 5S plus 22. 5S plus 22. So this is the simplification of this matrix multiplication. Now you have to multiply with 1 and 1 here. Okay, and then you have to divide it by S square plus 8. Okay, now simplify this. This is a 1 cross 2 matrix. This is a 2 cross 1 matrix. So 1 cross 2, 2 cross 1 should be 1 cross 1, just to simply multiply matrix multiplication. So it will be 3S minus 21 plus 5S plus 22. Okay, so divided by S square plus 8. So this is the final answer. So what is the final answer? 3S plus 5S should be 8S plus minus 21 plus 22 should be 1 divided by S square plus 8. I think this is your transfer function. 8S plus 1 divided by S square plus 8. Just this is a matrix multiplication. You have to draw. If any the mistake from my side, then please be clear. Okay. Are you following how I have written that?
Yes, sir.
Okay. Let me see. Thank you. So this is something related to the transfer function. How we find out the transfer function of any state model is given to you. Just use that formula. Transfer function is nothing but C into Si minus A inverse into B. Now here, after getting the transfer function, if they will ask you to find out the closed loop pole location, transfer function is this is the total transfer function C of S by R of S. So you find out the closed loop pole location. What you do S square plus whatever the denominator term, you just equal to 0 and find out the pole locations. Okay, like that. So next question, let's come to question number 6. Similar, the question number will be 6 will be like that. Okay, I will not solving here. This Y of S is nothing but C times of Si minus A inverse into B. Okay, C is this one, this is C, this is A matrix, this is B matrix. Put in that formula and find out the answers. Okay, so this is same formula wise questions. Let me come to question number 7. This is the This is the typicality of the how we will proceed to the last part. Our main aim is that we have to find out the complete system response. So complete system response is given. Now you see the equations. How the equations is given. X star equal to ax plus be and y equal to cx. This is the general state vector. Okay, it's a general state vector. But you see here x star equal to ax is given, means b vector is not given, means input is not there. Sometimes input is not there, so u is not there. So I told in the first slide that if x star equal to ax is given, b is not given or u is not given, this is a homogeneous equation. So this is a homogeneous equation. So here in homogeneous equation input is not there. Okay, so b is 0 or input is 0 means u is 0. As u is 0, you cannot find out b vector. Okay, or b matrix. So here this is a homogeneous state equation, x star equal to ax and y equal to cx. This is the equation is given to you. How to find out the complete time response? So complete time response formula is there. Remember that how to find out the complete time response. So the complete time response, you have to find out x of t. Okay, how to find out x of t? Because you know from the last question we are finding out the transfer function. Transfer function means we are finding out output y of s divided by input. Input is u of s. This is the total. Okay, we are finding out the transfer function. So from that, if you multiply u of s, suppose the transfer function is transfer function. If in this equation, if I found out the system response means you have to find out y of t or y of s. This is nothing but a transfer function into input. So if you take the inverse Laplace transformation, you will get y of t, L inverse of transfer function into u of s. Okay, this is the general equation. This is the output system response. This is y of t. That you need to find out there. So now how to find out that one? So first of all, this is your x star equal to ax and y equal to cx. First of all, we have to for finding out y, you need to know what is x, right? Because if you know x, then you can find out y by multiplying cx. For first of all, we need to find out what is x of t. So for that, this x of t is equation is e to the power at. Just write down this formula: e to the power at into x of 0, okay, plus L inverse into L inverse into x t. Instead of writing out the whole equation, otherwise should be confused here. So how to find out x of t? The x of t formula is given by x of t is L inverse. Okay, this is SI minus A inverse. The matrix we already calculated. How you calculated, you know. So this will be L inverse of SI minus A inverse into x of 0. Okay, so first of all you find out this value Si minus A inverse and take the Laplace inverse of that, multiply with x of 0, that will give some part. Another part will be there, that will be L inverse Si minus A inverse into B into U of S. This complete vector you need to multiply and then take the L inverse, that will give you x of t. This formula you have to remember always. Okay, this formula you have to always remember how to find x of t. If you know x of t, then y equal to nothing but c into x of t. Okay, this is the total response you need to find out. But in this question, for simplicity, your b is 0. So if b is 0, this part will be 0. Okay, if this part will be 0. So only what you need to find out, L inverse Si minus A inverse plus into x of 0. Okay, that will gives you x of t. So x of t is nothing but L inverse Si minus A inverse into x of 0. This x of 0 is multiply last two. Okay, so first of all you find out this value Si minus A inverse, उसका Laplace inverse निकालना है, then you have to multiply with x of 0, that will give you x of t. But in some questions, if b is there, then you have to use the second term also to find out. First of all multiply Si minus A inverse into b and then multiply with u of s and then take the whole L inverse and add this value. This will gives you x of t. Whenever b is there, this is a non-homogeneous equation. So this equation is a non-homogeneous equation. If u is 0, this is a homogeneous equation. So sometimes they will ask you to find out the complete response of a homogeneous equation whenever u is 0. For a non-homogeneous equation, u should be there. So this is the total equation formula. So you use accordingly to find out the system response. Are you clear how to find out that?
Okay.
So I am not going to
Yes,
solve
sir.
you this because you already know how to find out Si minus A inverse. Just take the Laplace inverse. For the last question, if you want to solve, then I can help you. So for the last question, let's me Si minus A inverse is how much? This one is Si minus A inverse where we have calculated somewhere. This is Si minus A inverse. Uh, this one. This is Si minus S minus 2 minus 3. I'm just taking the last question for your simplicity here. Taking the last question.
Sir, one my question
Yeah, yeah, yes.
regarding exams, sir, because the control engineering subject is very numerical.
Right.
So, uh, within 3 hours, throughout the syllabus,
Yes,
and
actually, what you do mostly, my previous experience, I'm just telling you that I have already given a lot of NPTEL exams. So, my previous experience tells that if you solve only the assignment questions, okay, assignment questions plus the questions which are solved in the class, that will be enough to solve you 80% of the answers. Okay, if you don't know anything, just practice these assignment questions and the question that are professor is solving in the class, okay, like example questions, then 80% will be covered there. Another 20% is just some of the modification they will do because this is an all India level exams and they're doing by IITs, so they will give some questions which a little bit you have to use a mind, and this is some basic conceptual questions. So uh, just practice this, okay, 80%, 85%. If you solve 80% in 2 hours or
means
2.5 hours,
okay,
then another 30 minutes you can use a brain to brainstorming questions should be there, you can
means
try.
if we study the assignment properly and lectures
Yeah,
uh,
not go
problems,
to the
then
lectures all.
70% we can score.
Yeah, yeah, of course, if you solve assignments and don't go through all the lectures, only go to the lectures, example questions, then you are able to solve 75% to 80%. That's assurance. Okay, another 20% always there in any exams or go, always the 20% should be there which are tougher questions that you have to use a brain, means that you have to think critically to answer that. Okay, always it will be there. So so practice that always. Otherwise, if you get 40-50% marks, then that don't count anywhere. Okay, if you got around 60-75% marks, it is a good count in NPTEL. Okay.
Yes, sir.
So already you know. Okay, from let's come back to the question. So you already find out the SI minus A inverse term here, which is nothing but here you can
One
see
more query, sir. You will take the revision class because on 20th, control engineering is exam, 20th April.
28.
Yeah, 20th, 20.
Okay, on 20. Okay. Sir, I will just take another two classes. One is actually an extra class I'm taking, and actually this is the 11th week and 12th week, and I think in between, I think this Friday I will take one class. In that class, we can discuss the doubts from the week 1 to week 11. Okay, any doubt is there?
So on Friday, coming Friday.
I think this Thursday. I think this Thursday, sir. I have booked their slot, but I don't know whether it's allocated to me or not. If it is allowed, then this.
There is a one revision class.
Yeah, you just see the notification because I think they will notify on the portal. Just
Okay,
check that,
okay.
okay, when it will be
Yes,
there.
sir. Because it is good for recap and revision.
Yeah, of course. Yes, okay.
Okay, thank you, sir. Thank you. Please continue.
Okay. So you know SI minus A inverse, how you find out the adjoint A divided by determinant of A. So this is the adjoint A, this term. I'm just describing the last question how I SI minus A inverse you find out this term. This SI minus A inverse. I'm just taking that value here. Okay. So I'm just Si minus A inverse S minus 2. Just writing down something. Okay, don't tell the exact values to me. Just writing down. Suppose this is the Si minus A S square plus A2 as there. This is just then what you do? Then you take the inverse Laplace transformation of this. Inverse Laplace transform means individual term you have to find out the inverse Laplace transformation. S minus 2 divided by S square plus 8. Similarly, 3 divided by S square plus 8. These are the 4 terms, right? 4 divided by S square plus 8. Okay, and this is S plus 2 divided by S square plus 8. Then find out the inverse Laplace transformation. After finding out the inverse Laplace transformation, then we'll get 4 terms. Okay, the 4 terms will be in time domain, and multiply that with x sub 0. X sub 0 is given to you in the question 1 and 1. So you just multiply and find out x sub t. Similarly, once you find out x of t and just to multiply with c, then that will give the y of t. So it's simple, that simple. So like that you have to solve. Just but remember this equation 1 formula. This formula will be very helpful if you know, because you know how to find out SI minus A inverse calculation. Okay, then rest of the thing is just mathematics. Let's come to another. I'll solve another two aspects here. One is controllability, another is observability. Okay, so what do you mean by controllability? Remember that what do you mean by controllability? Okay, the professor should describe in the class, but controllability means a system. If I'm saying it controllable, okay, what does it mean controllable? Then it is possible to, okay, transfer, okay, you are able to transfer the initial state to the desired state. Suppose one initial state is there, I want to go to my desired state, okay, in a finite amount of time, okay, by controlling my input. How can you do that? You are now in a position, you want to go to a better position in future. You have to control the inputs, you have to control all the disturbances, all these things. Means by controlling the input, if you want to go from a initial state to the desired state, then the system is called controllable. So controllability test, how do in mathematics, how can you solve these questions? Suppose a transfer function is given, you have to find out first ABC matrix. So for this, I know I told you how to find out the ABC matrix for this type of question. Let the transfer function. So first, this is the third order equation. You see SQ is there. So this is a third order equation. 3 cross 3 matrix will be there. Another B will be there, which is a 3 cross 1 matrix. Another C will be there, which is a 1 cross 3 matrix. Okay. So now you have to fill all these values. Next, how to check the controllability? The controllability you can check by using Kalman's test. Okay. So it is called Kalman's test. Just use this formula to find out the controllability. So Kalman's test is saying that Q is a matrix. So Q can be found out. So how many terms are there? This is 3 cross 3. So you write down 3 matrices: B, AB, A square B. These are the terms you need to find out. If the fourth order is there, then you have to find out AQB, like that. So here 3 is there. So dot 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 I can write out. This is for n cross, this is a n cross 1 matrix. Okay, so 1 cross n matrix. Okay, but you see for our, in our problem, this is a third order equation, so we just focus on the first 3 terms. So Kalman's matrix is nothing but B and AB and A square B. This matrix we need to find out. Then we need to find out the determinant of this matrix. So first find out the determinant of this matrix. If the determinant of the matrix equal to not equal to 0, then the system will be controllable. If it is equal to 0, then it is not controllable. So first of all, I will fill this matrix, ABC matrix. You know how to fill it. So just go to the previous, watch this video, how I solved this question to find out the A matrix. Just I'm writing directly the coefficient here. This will be 0, 1, 0. This will be 0, 0, 1, and this will be minus 4, minus 3, and minus 2. B matrix would be 0, 0, 1, and C matrix is something, you can say 1, 0, 0. These are the 3 matrices. Then after finding out these 3 matrices, you have to set this B, Kalman's matrix, Kalman's vector. Okay, this vector is nothing but B. First you write down B. What is B? I am just writing B, AB, and A square B. So what is B? B is 0, 0, 1. Write down 0, 0, 1. What is AB? AB means you have to multiply A and B. Okay, this matrix multiplication you have to do after multiplying AB, because this is 3 cross 3. See, this is 3 cross 3, and they're multiplying with a 3 cross 1. So we'll got a 3 cross 1 matrix. 3 cross 1 matrix means you will just get a column matrix like that, B matrix. So you get some value, AB multiplication. Let's say the answer is 0, 1,
0, 1 minus 2.
minus 2, right? Then A square B is nothing but what? After you finding out AB, then AB में A square कैसे आएगा? You have to multiply AB with A again. A square B is what? A into AB, right? After you got AB matrix, then you just multiply with A, because this is 3 cross 1, 3 cross 3, this is a 3 cross 3 matrix, A is a 3 cross 3 matrix, AB is a 3 cross 1 matrix. So you got a 3 cross 1 matrix. 3 cross 1 matrix means a column matrix. So A square B. So in this AB matrix, you have to multiply A matrix. So you will get some answer which will be 1 minus 2 and 1, 1 minus 2 minus 2. So this is a 3 cross 3 matrix already formed here. Now this C, this is a Q matrix is formed. Now you first find out the determinant of this 3 cross 3 matrix. After finding out the determinant of this matrix, you see that whether the determinant is 0 or not 0. If it is 0, then it is non-controllable. If it is non-zero, it is controllable. So find the controllability of the transfer function. So I think the determinant of this matrix will be not equal to 0. So the system is not controllable. So the answer is not controllable. Similarly, another question is there related to the observability of the matrix. Suppose here actually ABC matrix I am giving to you for simplicity. Let A is here 2, 3, 1 minus 1, 1. B vector is 1 minus 1 and C is 1 and 1. Okay, these are the three matrices from this equation write down. Then observability say that you have to again perform the Kalman test for uh, observability. But here now the equation is something like this. Here I am saying Q observability. You have to form matrix like that. How to form a matrix like that? You have to take, this should be previous one is a row vector. See, this is a row vector. B square B you have to find out. This is called QC. Let's see, use for controllability. B square B like that. But now you have to form a column vector like that. CA square. If fourth order will be there, then it will be CA5 like that. But for our equation it is 3 cross 3 matrix. So these three matrix we need to find out. So what is C vector? C vector is no, this is second order matrix. So second order you only require C and CA. So we require only C and CA because you have a second order matrix. Okay. So first you find out what is C. C is nothing but 1, 1. And what is CA? Multiply C with A. You will get another matrix. What is that matrix? This will be again 1 is to 1 you will get. So C also you get 1 is to 1. Multiply C with A also you get 1 is to 1. Find out the determinant of this matrix. The determinant equal to 0. So find out the determinant of this matrix. If the determinant equal to 0, the determinant equal to 0, then it will be not controllable. So not observable. Not observable. If the determinant not equal to 0, then it is observable matrix. As simple as that. Okay, you got my point. How to find out the observability and the controllability of the question.
Yes, sir.
Okay, I'm just this is the last question I think. Yeah, so we have covered a lot of things. Just revise this. Okay, and you can able to solve any question on state space. Okay, but just do the assignments. Okay, maybe the assignments is related to some, if they will add some compensator also, that is no problem. You just know how to add a compensator. But these are the basics for the state space model, how you develop your state model and finding out the transfer function, finding out the system response, finding out the observability, finding out the controllability. Okay, so I'm stopping this lecture for today. Okay, so we'll meet I think on Thursday for the compensation class. I don't know, but we will see and check.
So thank you, sir, so much. And whenever you take the revision class, so please
No, I cannot
inform to
notify,
the.
sir, but you have to check the portal, okay? Because I have to check the
Yeah, yeah,
portal and
sure,
come
sure,
here,
sure,
right?
sure, sure. Actually, control system subjects teaching three faculty, three I think TA. So
No,
that's why it gets confusing. Yes,
okay, okay,
physical class always on Monday.
my class is on Monday, okay, right?
So we will meet in next Monday, right?
We'll meet on the next Monday for week 12, but before that, I think one compensation class will be there. Because I have
Okay.
filled the slot on Thursday. I remember that.
Okay, sir. Okay, sir.
Okay. Okay. Thank you so
Thank
much,
you, sir. Thank you
everyone.
so
Okay.
much. Good
Yeah.
night, sir.
Good night.
Thank you. Thank you, sir.